Okay. Hi, my name is Alexey Medvedev. I'm working for Meta, and I'm a chair of 3D Formats Working Group in Khronos. And today I'm going to present glTF roadmap for 2025. If you don't know, glTF is widely adopted open format for 3D assets. It's widely adopted by the tools, engines, and applications. The glTF specification is completely open and IP-free, covered by the Khronos. You can check the specification on GitHub, and this presentation will provide the roadmap for the new extensions and the improvements of the glTF format for this and following years. And because it's completely open on GitHub, I welcome everyone to join the ongoing discussions, and we specifically looking for the inputs on some uh, proposed extensions and directions for us. So please join us in discussions. You see the QR code on the screen, and please use it to talk to us. glTF is the foundational standard. We are working closely in collaboration with the different standards, including VRM, 3D Tails, MPEG, X3D, and PDF. LTF itself is a ISO standard, and we trying to develop extensions not only for general use cases, but we work on the market-specific extensions, and we definitely want to see more collaborations across industry. One of the core and fundamental glTF features is PBR materials. We started with the metallic roughness model in 2017. Since then, we are developing extensions that improve the visual fidelity and add the feature set for the PBR materials. On the screen, you can see the evolution of our material extensions. Last year, we implemented and added support for the dispersion and anisotropy extensions. We added support to our internal visual tools, including sample viewer, and along the way, that's the specification for the extensions. In development, we have the subsurface and diffuse transmission. Also, Khronos glTF PBR is available as part of Material X. You can use existing Material X nodes and implement the PBR shader if you want to. And our goal is to update glTF PBR model as Material X node graph with the full set of the extensions we already introduced, and we are planning to keep this going. Another huge evolution of the PBR materials as today is a procedural textures graph. Before, PBR materials were described only as the set of material parameters. This new extension proposed a way to create a shader graph and control over the inputs for the standard PBR material, and some sort of, you can imagine Material X. Some capabilities can be introduced this way that allows to create more flexible settings for the materials. Along the way, it's not only flexibility, but customization if it's necessary. And we expect the creators and asset creators and the actual software engineers will leverage this by introducing new complexity for the actual shaders. Another huge direction for us as glTF working group is spatial computing roadmap. That's a whole new set of the extensions that significantly improve the capabilities of glTF assets. As before, you can imagine glTF is the pretty much static and predefined set of necessary information for the 3D assets. With this new direction, we want to see an introduction on the smart assets. So that means we want to add the flexibility over control of the behavior of the assets. We want to introduce complex scene composition with referencing of glTF assets. We want to be able to describe the physical properties of the assets. And we were working on the new set of audio capabilities that will allow us to create sound rich environments and uh, some sort of interactivity capabilities for the assets. And we definitely looking for the inputs from the industry regarding those efforts. For each slide, you will see the QR code, which contain the link to the actual extensions or discussions regarding this. We'll start with glTF interactivity. That's the way how we can portable describe the how content should respond to user actions or events. Super typical way for the current industry to use node-based graphs. If you have any experience with the current modern 3D engines such as Unity, Unreal, or NVIDIA Omniverse, you probably understand this concept, visual scripting, that you can create the nodes, create the flexible graph based on the nodes, and then you can apply this to the content of glTF scene. glTF approaches to create the specification for this, not dictate the actual runtime implementation, but you can map this to existing engine logic or create new one if it's necessary. Along the way, we're bringing over some sort of constellation of the extensions that allow us to use interactivity efficiently. For example, KHR animation pointer allows you to address the properties of the glTF assets, and node hoverability or selectability allows you to control the flow over the node behaviors. You can enable disable nodes by the show and hide the nodes by the node visibility. And accessor float 64, it's pretty much mechanical, but describe the way how we can store the doubles inside the how to address the doubles inside the content of glTF files. This spec is almost ready. We're really looking for the not only for the inputs on this, but on the actual implementation. You can please use QR code and start to use it today. glTF physics is a distillation of widely adopted physics engine practices. And similarly to interactivity and other extensions, we are not dictate the current runtime implementation for this. We express the physical properties for the objects. Currently, we have two extensions in development. First one is implicit shapes that allows you to create the notion of the collision geometry. And second one is physics rigid bodies that allows to define the physical properties of the rigid bodies one. It allows creators to use procedural animation use cases or do any sort of physical responsive if necessary, and enable scene understanding that will greatly work with the collaboration with interactivity. For example, buttons might have the collision boxes, they will react on the some sort of events. And rigid bodies should be familiar for the any sort of engine users. And we describe the properties that you can use and materialize in your assets. On screen, you'll see QR code that you can try glTF physics today. And this animated GIF shows this is completely one static glTF object, but as you can see, it has a lot of animations and happening just because physics works. Another big direction is external references. One of the fundamental problems with the glTF in the current form, glTF 2.0, does not allow to reference external glTFs inside. And this is our approach to be able to create the complex scenes or answer some questions such as placement, configuration, cache reuse, personalization, deferred loading, LODs, and mesh variants. Our current mental process regarding this, we want to create a new file format and that will contain the references to the external glTF files. This is QR code. Please join our ongoing discussions. We definitely looking for your input about this. glTF audio, we are working on a new extension that the name is KHR Audio Graph. The idea is to create, similarly to interactivity or procedural textures, to create the graph for interconnected audio nodes that we can define the final audio output. We see this as a superset of previous proposed audio extensions, such as audio emitter or audio spatial. We did some work to normalize with web audio and other popular game engines and sound engines. So we expect the nodes, the concept of audio nodes, audio processor, and audio graph itself to be super familiar to any engineers or content creators that working on the sound. The spec itself is in draft state in development mode. Here you see the QR code, and please join the discussions and let us know what do you think about this. Besides the actual extensions development, we have a huge tooling effort in our working group. We develop and maintain a bunch of tools for the ecosystem and for industry, including Blender and our internal sample viewer. We have glTF compressor tool. We're working on research on the complex scene I showed before. This is an existing project on GitHub that you can play with. And we are working on procedural textures. And our goal for this year, actually, it's continuing development and maintenance of the glTF ecosystem across all the tools, but we want to support those new introduced extensions, such as interactivity, physics, audio, and external references. Along the way, we're working on the actual testing suite solution for the glTFs. We expect an increase in complexity regarding the, especially interactivity and interaction, this extension with the future and existing content of glTF files. So that requires a specific handling in the testing infrastructure. And besides that, we still investing in KTX features, roadmap and tuning. USD and glTF interoperability is always a high priority for our working group. We see USD and glTF as complementary formats. We serve different needs. We closely working with AOUSD working group, especially in Metaverse Standards Forum panel. We have initial projects such as FBX migration that's been strong demand from industry to move out from FBX. We're trying to see how we can close the gaps and make FBX obsolete. And we definitely care about USD and glTF interoperability. Our terms are pretty much well described by the specification that we have. Please follow the link And if you have any inputs, it's really appreciated. And one more thing, this is really hot topic. It's actively being discussed in multiple Metaverse Standards Forum town halls, and we have presentation for such big names as Radiant Fields, New York Times, Niantic, Meta, NVIDIA, Play Canvas. So basically everything that you can see on the screen, and Cesium, Bentley, sorry, and other ones. So we discussed starting from the high level concept, ended up to technical details, and uh, the goal is to try to understand, are we ready to work on the specification for this or not? And seems like we have a growing consensus. That's the time to start to build extensible splat standards. We are looking for collaboration with the other formats such as Niantic SPZs. And this is a link. Please join the discussions. We've got one proposal from Cesium regarding the glTF, Gaussian splats implementation, but we in really early stage of discussions. Any input is really welcome. And this is, I think, my final slide, which is glTF roadmap overview. You can see where we at this year and what we're going to work in the future. And that's the time for the questions.